This lesson is on multiplying rational expressions. Just as we did before when we finished simplifying rational expressions, we want to factor everything. So typically what happens if you don't factor is you look at something like this and we end up trying to multiply this binomial by this trinomial, which would give us 6 different terms. It would be very easy for us to make a mistake. And then I would get another 6 terms on the bottom, and then I would try to reduce that, and that is just crazy. So instead, what we do is we factor everything. We try to get rid of things that we can on top and on bottom, and then see what we have left over. Again, we do want to restrict the domain whenever possible, so let's do that as soon as we are done factoring. My numerator, I'm going to rewrite that as 7 and then x plus 1. My denominator doesn't reduce, it's just x plus 4. My second numerator could be factored into x minus 5, x plus 4. And my second denominator, I'm going to take a 7 out first, which leaves me with x squared minus 6x minus 7, which would give me 7, and then x minus 7, x plus 1. X minus 7, x plus 1. So now that I have everything factored, now I'm going to restrict my domain. So I'm going to say that x cannot be negative 4, positive 7, or negative 1, because that would make my denominator 0. And then I would reduce anything I can. So I have x plus 1, x plus 1. Now, does it matter that 1 is on one fraction and 1's on the other? No. As long as 1 is a numerator and 1's a denominator, then we're okay, because if I wanted to, I could write my new numerator as 7 times x plus 1 times x minus 5 times x plus 4. So it really doesn't matter that they're not the same fraction. The x plus 4 will cancel, and the 7 will cancel, and that leaves me with just, that leaves me with just x minus 5 on the top and x minus 7 on the bottom, and then of course my restriction on my domain. So let's try a couple of practice together. Again, we're just going to, anytime we can factor, we will factor. So here, if I took a 2 out of everything, that would leave me with x squared minus 6x plus 9. If I took a 4 out of everything, that would leave me with x squared minus 9. If I took a 2 out of my other numerator, I would get x plus 3. And if I took a 5, I would get x minus 3. I haven't finished factoring because this one, because it has a squared value, and this one, because it has a squared value, probably can be factored further. So I'm going to leave my 2 on the outside. This one turns into x minus 3, x minus 3. Again, leave my 4 on the outside. This one turns into x plus 3, x minus 3. That's that difference of squares pattern. I'm going to rewrite these two because I've already factored those completely, and then the fun begins because I get to start reducing things. So let's see, I've got an x minus 3 with an x minus 3. I've got an x plus 3 with an x plus 3. I've got an x minus 3 with an x minus 3. This 2 and this 4 will reduce to 1 and 2, but I still have a 2 over here, so I can actually reduce this to 1 and reduce this to 1. And goodness, what do I have left? On the top I have a 1, and that's it. And on the bottom I have a 1 and a 5, which is, of course, 5. And the restrictions on the domain would be plus or minus 3. Negative 3, positive 3, positive 3. And that's it. Let's try another. Notice here my second value, my second factor does not have a denominator. Just write it over 1. So this looks like a difference of squares pattern. I've got 2 perfect squares subtracted, so that gives me 2x plus 3, 2x minus 3. This one looks like a perfect square trinomial. That would be 2x plus 3, 2x plus 3. How did I know it was a perfect square? Because this is a perfect square, this is a perfect square, and if I took their two square roots and multiplied them and doubled them, I get that middle term of 12x. This 6x minus 9, I'm just going to take a 3 out of everything, and that gives me 2x minus 3, and just over 1 is just fine. Let's go ahead and restrict our domain. X cannot be negative 3/2. That's it. Again, you can set that equal to 0 to solve. I'm just doing that math in my head for the sake of not making this a 30-minute video. And if I divide by 2, again, I get that negative 3/2. And then, of course, I'm going to reduce. So this reduces, and that's it, unfortunately. So there's nothing I can do about this because this is a plus, this is a minus, they're not the same. I can't use my little negative trick. I could only use that if one of them had a different sign on the 2x, you know. So now I'm left with 2x minus 3 and 3 and 2x minus 3, which I will write as 3 and then 2x minus 3 squared. The denominator, I only have 2x plus 3. Be very careful on this. I have a lot of students who try to reduce these two 3's. This 3 is a factor. Notice it's being multiplied by things. This 3 is not a factor, it's just a term. It's not being multiplied by anything, so it would have to be something that I have pulled to the outside to be a factor. Try this one on your own and then press play to see how you did. Again, factor everything first. So I'm going to take a 3 out of both of those, so that's y minus 2. 6y, just going to leave it just like that. This factors into y plus 2, y plus 1. And this factors into y plus 2, y minus 2. So again, if you're having trouble with the factorization, then really you should go back to last week's lesson where we talked about how to factor everything, all of the different, the tic-tac-toe factoring, taking out a GCF, if it's a perfect square or a difference of squares. That should be the easy part here. And now we are, you know, doing the next step, which is multiplying rationals. So let's see what I can get rid of. I've got an x minus 2. I've got an x plus 2. And I have a 3 and a 6. Again, don't worry about the fact that there's a y there. The 3 reduces to 1, the 6 reduces to 2. The y just stays there. I'm left with 1 and y plus 1, which is just y plus 1. And the denominator, I have 2, and that's it. Restrictions on my domain, x cannot be plus or minus 2 or 0. If I set this equal to 0, I would get 0. If I set this equal to 0, I would get my plus or minus 2.